Thanks a lot. I wanted to still do the introduction in French. I've learned French for 5 years in school, but my wife, she told me, don't do it. You need to have a certain style. You need to have a certain elegance to speak that language, and you just spoil it with your thick German accent. So I will just stick to English then. Yeah, so I'm Rainer, as Eunice already introduced me. I'm from Austria, part of Angular Architects, and next to the workshops and consulting that we're doing, I'm also trying to be active in the open source community. So I'm also a member of the NgRx team. And as you have seen, this talk is mainly about state management. So what I want to do, or the agenda for this, is that I will use, of course, the NgRx Signal Store as an example, but I want to more focus at the very beginning on this concept of states, what it is, how it is integrated into Angular, a little bit more of theoretical input, and then we will take a look at the Signal Store to see how it could be solved by one of the existing libraries. So as I said before, we are doing a lot of workshops, and whenever the topic of state management comes along, somehow people start doing something like this. So they say, no. When I say, do you know NgRx? Do we want to take a look at it? They say very often, no, like they have been traumatized in a way. And that's usually always the thing when they have been using the global store, the NgRx global store, and not just using it, but overused it. So the global store is meant to be used for something very big, and very often state management is a little bit smaller, and as I said, then you're a little bit scared away if somebody starts to say, do you want to use an explicit library for state management? And then I always have to explain a little bit, look, there are different versions, but this kind of statement, I don't need state, this is something that we first of all have to discuss. Because my argumentation is that when it comes to the term state, it's actually the main essence when it comes to single page applications. Let me quickly explain what I mean. When we say front-end, then the main goal of a front-end is obviously to render the UI. So this is obvious. So you would say maybe that's the primary goal of the front-end. But in the end, I don't need to use a single page application in order to make a front-end. I can also do server-side rendering, and that's it. The question is always, should we want, or do we want to use a front-end which can dynamically change itself? And this is then where dynamic state changes become important. So we do have a static state, and if we say whenever we want to update the state, I need to go back to the server, then we don't have to use a single page application. But what we want to do is that we say we have JavaScript, we want to be able to dynamically react to certain user events, or maybe if we are loading some data, these events will in a way manipulate some kind of state in our application, which then means our UI, our front-end framework is then again updating it. And for me, it's really the main essence for using JavaScript on the browser is that we have this dynamic behavior to change the state. So it's all about the state in this case. And that's really important to me. I never saw it like this. Just 3 months ago, there was a talk from Sarah Dresner, and she actually said this, we have JavaScript for dynamic behavior in an application. It is all about the state in this case. Good. Let's take a look at the way how Angular has been evolving over time towards state and also towards state management. So when we say, and let me move forward, the way how Angular worked before signals came out, it was very event-driven, I would say. So as we know, we have a certain state in our application. Just imagine some kind of a property that contains a list of user entities or something else, and that is then rendered. Then comes an event that could be the user clicks on something, or the user's an HTTP request was just responding, and then the state, or then the event of the answer is then taken on by our framework. It processes this data, and then it ends up in a new state, in a state change. And it goes on like this. So we have then multiple events, and most of those events will then update the state. That's the way how it works. And what Angular has been doing all the time, since until signals arrived, Angular said, look, if there is an event, I'm listening to the events, because the probability is then very high that something has changed in the state as well. So we were listening to the events, or Angular was listening to the events and was then synchronizing or was executing the change detection to update then this thing in the browser. If you look at this thing now, at this drawing, then we have to realize that there are also other very special type of events. It could be an event like an event listener that says, I'm only there to debug certain things. So I want to do just a console log, but I'm not going to change the state, which could be a problem, because if I'm now listening to all the events and I say just because an event runs, I now need to update the DOM, these are just wasted resources. It can also be the case that multiple events run synchronously. They change the state, but then we say, okay, why do we even have to process when there are 3 events? Why do we have to process the first and the second event if only the third one really gets through and is then really also updated or is then updating the DOM? It's the same. It's also a little bit of a challenge. And the obvious approach in this case, and if you see the drawing, I would say it is obvious that you would then have something like signals. So you want to have then a certain state, kind of state, which is able to notify us. So as a framework, I can say, why do I actually listen to events when I'm really only interested if a certain state has updated? Yeah, then we have signals. The signals are representing state. They're holding state. State is there all the time. Now the framework can say, look, I'm just going now on the signals level, and I say, my dear signal, if something has changed, then you let me know, and then I'm updating the DOM. And then I don't have to care about like events which don't do anything or multiple events which are executed synchronously. It's very simple. And this is what we currently have with this signals way. We are not there yet. At the moment, I would say we are in a hybrid mode. But if we see then signal components coming up, you only can use a signal in a template, and then the state change will trigger the DOM synchronization and not the events anymore. So Angular has really kind of put it down very much on the state as the first kind of point of contact to our application. In other words, state is becoming more and more important in Angular, and then of course also for us. State is something, or the concept of the state is not something new. Other frameworks have it as well. There are some frameworks which don't use signals, but most of them, except React in this list, use it, maybe with different names. But even React, so this concept or this statement of I don't need state is completely wrong, because if you just look at React, it has use state. So how more obvious can it be? So state is always there. You can't have a single page application without state. I hope I've made this now clear. So the real question is not, do we manage state? The real question is, do we want to manage state on our own? Do we want to kind of reinvent the wheel? Or do we want to use a separate library for it, which kind of fulfills or which brings certain functionalities with it? That's the main question. It's not if you have state or not, it's more how you want to manage it. And if we look now at state management, at these explicit libraries over time, then we would say, well, in the beginning, we had Redux and the NgRx Global Store. This is where I meant before. This is more this traumatization phase where we used it everywhere. And then we saw there is a lot of boilerplate code necessary. And everyone was saying, no, I will never touch this again. But we learned from it. So there was this kind of understanding that we need a more simpler state management than what was NgXS, which kind of tried to improve the boilerplate code already a little bit. And over time, we have then seen other state management libraries which were more focusing on local state, because they said you don't have to globally manage state all the time. Very often, state is only localized to a certain component or componentry. So we have here Akita, Rx State, where Yunus made a video about it. I think it's the only video about Rx State. And then also the successor of Akita, which is called ELF. So we had very lightweight state management libraries for only parts of our application. But then we moved on. So at the moment, for those of you who are not using Angular, but another framework, I would say this is news from yesterday, that React Query, Tanstack Query is a thing. But for us, the Angular developers, I would say it's quite new. It's currently in development. It hasn't been released yet, but we have now very opinionated state managements. And I would say Angular query says, I am focusing only on this server state. So I am focusing on that state that always needs to persist, it needs to be synchronized with our backend. A very specialized niche, so not niche, it depends on the application, but for a very specific use case. And then we also have more generic state management libraries, which of course also want to be as lightweight as possible. And here, as I said, the obvious one would then be the Signal Store. From NgRx, yeah, you see I switched the logo. I'm using now the new one. And this is the one that I want to focus on. So what I want to do now in the next 20 minutes is that I want to show you how a service would look like if you say, I don't want to use any state management library. I want to do everything on my own. And then we just check out what the Signal Store would bring into the game, what kind of challenges it can fix, and so on and so forth. So, this is very, let me quickly improve. Can I do this? I hope I'm not destroying the resolution now, but I don't see anything. It was just too large. It's good, it's good, it's good. Yo, no, it is not. So we have a quiz application, and the way how it works, let me quickly open it. Quickly run it as well. So I say here, run the application. It's this example that I use for most of my talks. It's a simple quiz. So you're getting a list of questions that you can answer, and then the application will tell you if you're right or wrong. So quickly, let's go to a quiz that you see what I mean. Here we have a status, then I click on some answers. Yeah, the way how a normal quiz works. So the implementation is the more interesting part. Here is the quiz component, and you see it doesn't do that much. The quiz component has delegated all its logic to the quiz store, which in this case could be written by myself. And it has also done the same with the UI parts. So the template is also very small because it's using UI components. That's not part of this talk. I have here my own quiz store. And I would say this is already an implementation which is already nice. I'm kind of proud of it. It's very structured. It's very clean. And you see the typical elements that you will require for any service that is managing a state which is more than just one property. So you see here, I'm at the very beginning, I'm defining here my state. And I say, well, the state here is, of course, a signal. Yeah, so with Angular signals, we have a very opinionated approach from the framework, what we use for state. I'm putting here all my properties that I want. Then I have here my slices. This is always something you need to use or you need to have, because if you have a big signal, you don't want to provide this big signal to all your components. You want to provide optimized slices, optimized versions of that signal. So in my case, I would, for example, say there is one component which shows the question. There is one component which then maybe shows some kind of status information. And I don't want to give my component for questions everything. I just want to give it the signals of the signal containing the questions, because it should not, let's say, start a change detection if something in the time left has changed, because the questions are still the same. So that's why we always need to use these slices. And you see already, there's quite a lot of manual work. This is more or less obvious what we have to do. We're just creating a bunch of computers, but that's the way how it is. State, by the way, this is private, ECMAScript private, meaning nobody from the outside of the service can access it. Very important. What you always have with such a state is a set of derived values, and you always have logic around it. And you see here, I have here my computed. There's just one derived value where I say this is then calculating the status for me. I've extracted the status calculation that I can keep it short. And then we always have the logic. And in this case, the logic contains of a very intuitive way on how we want to deal with reactivity, on how we want to deal with effects. We will see later what this is all about. We have then also here the constructor, where you see I'm starting something which is the countdown. And somewhere else I have then also here the method to answer the question. And this is this kind of structure where I would say that you always have if you do this local or self-written state management. And there are now some things where, and especially now for the use case for the Signal Store, where the Signal Store can help you. I want to have a standardization. So as you've seen before, I wrote this very structured. I always started with the state, then the slices, computed, and methods. But this was just for the quiz service. I have no guarantee that somebody of my colleagues would follow the same structure, or if they have any structure at all. It could be the case that they are just mixing things. The slices maybe in the beginning, then a method, then a computed, then another method. And I don't want this. The larger my services are becoming, the more I need to have a structure. I need to know where do I have to look in my service when I want to see what state the service contains. Where do I have to look when I want to see the logic? So this is what I mean by standardization. And of course, then also the slices, if you have seen it before, that's a lot of manual work. I have to write quite a lot of computeds, which I would say is, it's obvious what I have to do. So there is not really something that I have to think about. It's just, yeah, don't want to say dummy work, but it's very easy kind of to automate. And this is already the first set where the Signal Store helps you. So the Signal Store says, look, if you use me, then I will give you standardization. I will also give you this the slices automatically, and I can guarantee you that you don't have this kind of boilerplate code anymore as it was with the global store, and to the outside it still looks exactly like that service that we have written here. So if I would then say I have the quiz store service TS, I'm just writing the first one on my own, just to give you an idea. Then the way how it works, for those of you who haven't seen it, that you say, okay, how do we call it? We just call it quiz store service in this case. And I have now a certain function, which is called the Signal Store. And that function allows me now to kind of configure a new class which is generated. And in order to configure the Signal Store, I have now, I would say, predefined opinionated elements that I need to have in my service. We have the state, we have methods, we have the computed. These are, I would say, are the three main functions, three main features. And then we also have additional ones, like if we want to add certain properties, or if we say we want to kind of do something at the very beginning, hook events, something like this. And the way how we define now the states, the methods, the computed, works very easy. I just need to say I have a state with state. And this is now the place where I'm defining what state my signal should contain. In the end, what I need to do is that I go here to that signal already and copy it. And I'm just putting it here, this object literal. Don't have to do anything else. Now the state is defined. What the Signal Store now returns, as I said before, you need to see the Signal Store as something which we don't have that often in Angular, but it is a function that generates a class, not an instance of a class, but it generates a dynamic class, so to say. And I'm going now to instantiate the quiz store on my own, just to show you what kind of properties it now has. And if I now say here quiz store, then you see that all of a sudden, all these properties that I have defined in my state are now also there. And they are not just properties, they are now signals. These are the slices. They are not the properties of the state. These are now the slices that I would have otherwise had to create manually. So I don't need to care about this anymore. All the state properties are already slices. They are normal signals, which means I can also call them. Then my value here, it's just a question. It's just an array of questions. And it's not just slices. It's not like that the first level of the state are the slices. We also have deep slices if we want to. Because if we have state which is nested, and I have here one use case, like this meta, I mean, the use case here is a little bit unrealistic, but let's just say I have two components, where one component needs to have a signal of version, the other one wants to have a signal of last updated, then I can drill in. So I can say, I want to go to meta, but I don't want to stop there. I also want to have now a signal for the version only. which means only if this version value changes, then this signal will fire. Again, if I would have now a component where I say I need to be very sure that it only updates the DOM if version changes, then this is exactly what I need. So deep signal, that's what we have here. Automatically, we don't have to do anything. We just have to say that's the state. The thing with the, what was the other one? Sorry, I need to go back. Standardization. Yeah, so standardization is of course now obvious with state. We also have then something which is called with methods, and then we also have something which is called with computed, and this is what I meant. I know exactly where I have to look for if I want to search for a certain element. The next thing where the Signal Store will help you is when it comes to state encapsulation and immutable updates. Let me quickly go back. So if we would now say, okay, I want to kind of now update the state in some way, then the way how it works is that I say I want to expose now a certain method which is called setTitle. Yeah, very simple. The way how it works, we have here our place. This is the location for any logic. setTitle is some kind of logic. So what I'm doing here is that I'm providing here a function which returns an object literal containing all the methods that I want to add. In my case, I say it's just the title. So I say here title.string. And as we all know, when we want to update a signal, then we have to do this immutably, which means I always have to clone the existing value. And this can lead to some issues, especially if we clone it and we don't clone, we forget about it, because we are not getting any runtime errors or any exceptions. It just doesn't work then. And here again, the Signal Store says, no, I'm going to help you. You don't need to do this cloning all the time. You don't have to think about it. You have a function where you say patch state. I think the name says it all. It says, you just tell me what values you want to have changed in that signal, and I will do the rest for me. So in my case, I say, well, I only want to update the title and nothing else. So I don't need to clone it, don't need to care about potential issues, just say patch state and that's it. This patch state, together with the store, also has another feature. It says encapsulation of the state. We have here a service. Nobody from the outside is allowed to change the state. Only we allow it by exposing certain methods, which are then internally updating the state. And this is very well protected. Because if I would now say I want to run patch state here on the quiz store, and I want to set the title now on my own, like NG Baguette or something, no, this will not work. We will get here a TypeScript error, because TypeScript and patch state, the typing system, is aware that this patch state is not executed inside of the Signal Store, but outside of the Signal Store. And that's why it's just not allowed. And again, this is built in. We don't have to think about it. These kind of best practices, those things which you usually want for those kind of services, they are just there. That's just non-opinionated. What I didn't say before, that the quiz store is also already a service in Angular. So you can just say inject, and it will already be there. In case you want to have a global service, then you have here one option where you can say provided in root, which means now the service is globally available. If you don't do this, then you need to provide it locally. So you can switch between local state management and global state management. Good. So encapsulated state, immutable updates. I think you have seen what I mean by this. And now comes the more interesting part. The whole discussion with, do we need RxJS with signals? Do we not need it? Is it some kind of in the middle? What I think, at least this is my opinion, that given the history in Angular, RxJS will stay. I think RxJS will be replaced in a lot of parts by signals, especially in those parts where RxJS was used for state. So the behavior subject was used by RxJS to hold a state, and these things are now going to be replaced by signals. But what will not be replaced is the actual place of RxJS, which is this event handling. And if you have very complicated event management, that you say multiple events are coming together, you probably want to deal with race conditions, then this is where RxJS shines. But I don't think that we will do so often, we have to deal so often with multicasting, with the share operators, with instantiating a new observer, with subscribing, with unsubscribing. The only thing that we will do is that we will only provide the pipe operators, and the rest then will be done for us. And the Signal Store already contains such a thing. There's also, by the way, another library which is called NG Extension, which also provides you with a set of utilities where you can very easily integrate RxJS in your application without kind of overflooding the complete code base. The way how it's done in the Signal Store, and now I'm going to switch over to the full version because I have it already here. There is something which is called Rx method. And let me quickly explain what this is all about. The Signal Store says, you can give me an ID for the quiz, and I will do, yes, sorry, just thought you want to ask a question. The Signal Store will say, look, you can call set ID, you can give me a signal if you want to, and if the signal changes, then I will load the new data for this quiz. What that means for my component, if I go back to my quiz component, then you see here that this quiz component is using the ID, it gets it as a property binding in that case. So it says here, input required, we are getting here the normal signal, and I don't want to create now an effect, because with effects you always have to deal with implicit tracking, you also have to deal with unsubscription in that part, and because it's an Rx method, I can provide here the signal as it is without calling it to set ID. Yeah. So what set ID is doing here internally, that it will create an effect which is now tracking this ID. It will do proper tracking. It will also do proper untracking, so you don't have to care about it. But additionally, you can now deal with changes of that signal like it would be an observable. So this means I could now manage race conditions. I could say if the signal for some reason changes multiple times, then I can apply a switch map. Because I say I don't want to, again, wait for the former response if I already know I need to load some new data for the new quiz. And of course, if we have here a pipe, I can also use other things like a debounce time. I can do a filter. I can use the complete portfolio that I get from RxJS, but I'm not exposing now RxJS to the rest of my application, meaning that my components who are now calling set ID, they are becoming, and they are now getting back an observable where they have to subscribe and do all that stuff. No, they don't even know that I'm using RxJS. I'm using RxJS here very pinpointed, so to say. Good. If you look at the other code, which is what I'm not going to do now, then you will see that the default implementation with effect has some issues, especially with the tracking and also with the injector and all stuff. So this is something which you get also for free, and not for free. I mean, yes, the Signal Store is of course free, but you don't have to do anything about it. And then the last thing is the extensibility, which I'm not going to show here because I would say it's too advanced. But the thing is, you very often might find yourself having here certain functions of a Signal Store where you say, it would be nice if I could extract this logic and reuse it in another Signal Store instance. For example, you can say you have a feature for the quiz store where people can add comments to it, so comment the quiz itself. Maybe you can upload files like attachments or something. You can all implement this logic here into the quiz store, but then you could say, I actually want to have this feature of adding attachments, of adding comments, a generic feature, and I want to use it in another Signal Store. And this is something, trust me, which is extremely easy when you're using the Signal Store. You don't need to deal with classes, inheritance, all that stuff. It just works. If you're interested, then yeah, maybe I can show it to you later, but as I said, it is very easy. Now we come to the summary. So the title of this talk was vadis state management. And in the way, do we need state management in the future, especially when Angular now provides signals already as a state? Yes, first of all, there are different ways on how you can do state management. The signal store that I've shown you is very generic. It's a little bit opinionated, but there are also other state management libraries which are not that generic, but which are very specific, like Angular Query, what I mentioned before, server persistency. And the Angular team has always said, look, we know there are so many ways on how you can do state management, and that's why we don't bake it into the framework, because if it doesn't fit for an end user, then they have to switch the framework or something else. So we want to make it very generic, and we hope that state management libraries on top of it will then provide these different specialities. What is important, though, for any state management library is that it is based on signals, because that's the core state representation that we have in the Angular. And we see now that this is also coming up with all the state managements that we see they're upgrading themselves and making themselves signal compatible. Yo, that was it. I said I don't speak French, but at least one word or two words. Merci beaucoup.